Okay, so I want to go ahead and look at the Lesson 7-2 homework assignment, parallel lines and proportional parts and mid-segments. So, let me go ahead and start with a basic problem. I'm going to start with number 10, and then I'm going to go back to these problems over here, because number 10 is just very, very straightforward. This is something that we've done on the notes, and I'm happy to go over a problem similar to one of the problems from the notes. So AB is 6, and then BC is 4, AE is 9, and then we're going to go ahead and find the ED, and we're going to let's let ED be X. So this is now X, okay? And from this figure you can see that we got a triangle where one of the segments is parallel to the third side here. So that means we're going to be using the triangle proportionality theorem, which you can go ahead and look up on your notes. And basically the setup is this. You're going to create a ratio between these two segments and set that equal to these two segments. So I'm going to start off with 9. Okay, so 9 over x is equal to, well, 9 corresponds with 6, so 6 must stay up top. And then 4 is going to be right there. Then I'm going to go ahead and cross multiply. So I have 9 times 4, which is 36, and then 6 times x, that's 6x. So x is 6, therefore ED is 6, right? So that's 6. That's the answer to that problem. Okay? Very, very basic. Then you get to number 12, which basically uses the same figure. If I were you, I'd just redraw the figure and then start labeling that. Let's see. So let me go ahead and do number 12 with you all. I'm going to set it up, or I'm going to draw the picture for you, because I noticed that I noticed something, and I want to go ahead and show you what to do, and then you're going to go ahead and set up the equation for me. Okay, so this is pretty much our sketch of that original figure. So here we have AC, that's 14. So this whole thing here, y'all, this whole thing here, if you can see it, let me see if I can show. AC is 14, and then BC is 8, right? Oh, no, that's not BC. This is BC. BC is 8. And then AD is this whole thing here, which is 21, okay? So, as you can see, we have a triangle where the segment is parallel to the third side, right? But if we look back at this problem here, we had something here, 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 and here, and therefore we can just create a ratio between these two segments equal these two segments, okay? But in this problem, we have this whole thing here, this whole thing here, a number here, and we should call this x because that's what we're trying to find. So let ED be x, right? So okay. We don't, if you notice, we don't have anything here and here. So how am I going to create a ratio between these two segments and equal that to these two segments? Well, you're going to have to understand this is where you're going to use the part plus part is equal to a whole. That's the segment addition postulate, right? So if I have this part plus 8 equals 14. Let me go ahead and put that on the side somewhere. So I'm gonna call this a part. So I have part plus this 8 is equal to 14. Let's go ahead and solve for that part. So that means that 14 minus 8, that is 6. Right, so that means that this here is 6. Alright? And then we're going to go ahead and do the same thing. We're going to solve for this part here. I have, I'm going to go ahead and erase this now. I have part plus x is equal to the whole thing, which is 21. So then I'm going to subtract both sides by x. So the part is equal to 21 minus x. So this is 21 minus x. Okay? And that makes sense because, y'all, look. If I do 21 minus x, which is one of my part, plus x, which is my other part, and the whole thing here is 21, well, if we combine the like terms, negative x plus x, they cancel out, so 21 is equal to 21, okay? So that makes sense that our equation is true here. So then I'm going to say that you should now go ahead and set up the problem. So you should have something like this equals this. So what are you going to put here, 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 and here? Okay? So that's how you're going to set up the problem for 12. Alright, so let's go over... Now that I think about it, since I went over 12, do I really need to go over 2? Do I really need to go over 2? Because this one's a little challenging, but that idea is still there for number 2. So you can do that on your own. Here, let's go ahead and look at number 4. In triangle JKL, JK is 14, JM is 5, LK is 13, and PK is 9. Okay, so let's go ahead and label that. So JK is 15, and then JM is 5, LK is 13, and PK is 9. So I can go ahead and fill this in. I have 5 plus this part, which will give me 15. So that means that this has to be 10, because 5 plus 10 is 15, that makes sense. And then here, I have something plus 9 is equal to 13, so this is 4. So I gotta check whether or not that segment JL is parallel to segment MP. So we're gonna go ahead and check whether or not the cross products are equal, okay? So I'm gonna do this over this, so 10 over 5 equals this over this, which is 9 over 4. Then I'm going to go ahead and cross multiply. So 9 times 5 is 45, and then 10 times 4 is 40. Are these proportional, or are the cross products equal? So are the cross products equal? Well, if we look, 45 and 90, they are not. So 45 and 40 are not equal, so no, no. And the reason should be is that the cross products are not equal. And that's something that you should write, something like that, okay? And then here we have this mid-segment problem. Segment JH is a mid-segment of triangle KLM. Find the value of x. So the mid-segment is equal to 1/2 the third side, okay? So if you know that if JH is the mid-segment, then how long is this? How long is the measure of LM? Okay, so that means that, well, If this is 5, then how long is this side? Plug it into the formula here, and you're going to be able to find how long the measure of LM is. Okay. And then let me go ahead and scroll down and see what else we can do. Actually, hold up. Do I need to go over this one here? Oh yeah, we have to go over number 8. Okay. So know that I have a triangle where I have one segment parallel to this segment, and you can see that these segments here are congruent. So when you have parallel lines and two congruent marks, right, that means that these two segments here, 1 and 1, are congruent. So these two segments are congruent. That is using the it's pretty much this theorem here, the congruent parts of parallel lines. Because since that's the case, I can go ahead and say, okay, I can create a equation between these two expressions and create another equation between these two expressions. So 3y is equal to 1/2 y plus 20. And I'm going to go ahead and help you with this one because you have a fraction, right? Notice that you have 1/2 of y. So in order for me to eliminate this 1/2, I'm going to multiply this whole thing by this number here. Okay, I'm going to multiply that by 2. And I'm going to do the same thing for the other side of the equation, right? Because you got to balance it out. So I have 2 times 3y, which is 6y, which I have 6y, which is equal to 2 times 1/2, right? So now I'm just going to distribute the 2 to each term. So 2 times 1/2, or 1/2 of 2, well, 1/2 of 2 is just simply 1, right? So that's going to be y plus 2 times 20 is 40, then minus the y on both sides. So y is equal to 40. Or sorry, not y equals 40. Y is equal to 8. Y is equal to 8. Okay? So that's how you solve for y. And then over here, you're going to create an equation between these two expressions. And you're going to go ahead and do that on your own. Okay? So solve for y on your own. Let's see. So y is 1/2 of wy, or yx. Yx is 1/2 of wy. Okay. And then let's see, zx is 18, zv is 6, wx is 24, and yx is 16. Okay, so when it says determine whether segment vy is parallel to zw, if the cross products are equal, then those two segments are parallel. Okay, you are using the triangle proportionality converse theorem for number 14, and we've done a lot of examples where you have to figure out that missing segment, so I think you can do number 14 on your own. For number 16, however, it's saying, okay, well, I have zv, which is 8, and then vx, that's 2. Know that yx is 1/2 of wy. Okay, so what is wy? Well, we don't know what that is. We're going to go ahead and call that x. Actually, no, we're not going to call it x. We're just going to call it wy, just simply wy. Or if you actually want to call this x, then you need to call this x as well, okay? So make sure that you are being consistent on what you're doing. But in this case, let's just call it wy just to make it a little complicated and, easy to, or let's make it complicated so we can understand what we need to do in case we, set up our problems like this. So you're going to create a ratio between this and this, so 1/2 of wy over wy is equal to 2/8, okay? So then I'm going to go ahead and cross multiply. So I have 2 times wy, which is 2wy, is equal to 1/2 of wy multiplied by 8. So what's 1/2 times 8? 1/2 times 8 is 4, but don't forget the wy. So if I divide both sides by wy, I get 2 equals 4, and you can see that the cross products are not equal. Whatsoever, so I'm going to say no, cross products not equal. Okay? Cross products are not equal. And then 14, again, you can do this on your own. And then here we got some mid-segment problems here. So you can, let's see, this here. Know that, okay, so I want you to understand about, I need you to understand something about the mid-segment of the triangle. They are parallel to the third side. So we say that JH and JP and also PH are the mid-segments of triangle KLM. You can say that for this problem here, JP is parallel to its third side. Okay, so if I were you, if this is 57, how long is this angle and why? And then you can go ahead and figure out 20 on your own. 24 is using the 24 is actually using this theorem here, the congruent parts of parallel lines. And then number 25, you can basically set these two things together and then make these two segments congruent to each other. And then the same thing with 26. Take these, equal that, and then put those two congruent marks here because that's using the congruent parts of parallel lines theorem. Okay. Alrighty. I will now let you be. Oh, actually, no, there's more. Oh, there. I'm sorry. So let's see. 33. If ST is 8, TR is 4, PT is 6, and QR is something that we're trying to find. Okay, well, this is good. This is a little different because for number 33, what I want you to do is, let me go back to the notes. You're going to use this setup. You're going to use the small triangle over the big triangle, and if you're confused on that one, I highly encourage you to watch the notes video for that one. So 33, I want to let you try that on your own. And then 34, SP is 4, PT is 6, and QR is 12. Okay, that's still using the same setup, and you're trying to figure out what this side here is to figure out what this side here is. Okay, so try that on your own as well. $35 you can do. And then let's see, 36 is WX is 7, WY is A, WV is 6, and VZ is 8. You can do 36 on your own as well, because you have to understand that my hint is make sure that you are doing the segment addition postulate for number 36 to find one of the missing sides in order for you to create that proportion. And then you can do this on your own as well. Okay, that is all from me. So I am going to end the video.